All right, so William, are you, everything okay? All right, Lulu is about to join us and Jeremiah will be with us. Hello, Dr. Lulu, how are you? If you are, when we're in science, we are doctors. Doctors aren't just people who help you to stay healthy, but if you're a scientist or an engineer, many times you are called doctors because you went to school for a long time and you know a lot. So when we're in science, I might call you Dr. Blair or Dr. Poppert or Dr. Harrington, or I called Lulu Dr. Cheney, and here comes Dr. Storino to join us. So, all right. Yeah. All right, so 1, 2, 3. Yes, Addie? Oh, okay. Is she okay? Good. All right, so welcome to science, everybody. Welcome, Jeremiah and Lulu. Our goal in science this week is to become closer to being experts in the engineering design process. So last week, we started to learn how engineers solve problems. So we know that engineers solve problems and they follow a process that we call the engineering design process. So today we're going to learn about that process, and then I'm going to introduce to you the first activity that you'll have and the first chance you'll have to use the engineering design process. So to get us started, we're going to watch a couple of videos about the engineering design process, and then we're going to talk about what we watch. So again, with a lot of these science videos, they tend to be, they go a little faster than I wish. They're a little quick, but I think it's still worth watching them if you try to get as much as you can out of them. And then afterwards, I'm going to slow it down and talk to you about it. I do hear somebody creating a problem for somebody else. So remember, please do not create a problem for anyone else on the face of the earth. Okay, you could do it. And the way you do it is Kafudi and silent listening, totally focused. All right, so I've asked you a couple times. So thank you very much. All right, so I'm going to
Science is a blast.
Whoops. All right. So I can tell right now that I made a quick mistake. When we watch videos, usually they are coming off of YouTube, and YouTube does have advertising. I try advertising, meaning commercials. I try to get those commercials done so you don't have to see them, but I can tell you've got about 4 seconds of a commercial here that we're going to have to get through, so I apologize. It's a commercial about a science, a series of science activities, which would be cool to try to do. But after 4 seconds, I'm going to skip through this.
Generation Genius, a new teaching resource of science videos and lessons.
That looks good. All right, so here we go. This is the video we wanted. Crash course on the engineering design process. Crash course for kids. Crash course means it's a quick course, meaning a quick video, a short video about the engineering design process. So here we go.
I'm going to take a wild guess and say you've probably used the phone. And I bet you've enjoyed the benefits of a little thing we call air conditioning. You know who made those things possible? Engineers. We were just talking about engineers in our last video, people who design and build things to solve problems, and there are lots of different kinds of engineers. No matter what type of engineer you want to be, though, civil, mechanical, electrical, or a kind that doesn't even exist yet, there's a series of steps that all engineers follow when they're trying to solve a problem. This process is called, wait for it, the engineering process. Makes sense to me. So what sort of steps are included in the engineering process? And why do we need it? Let's go through it step by step and discover how awesome things are made. First thing you gotta do is just define the problem. I mean, before you can solve a problem, you have to figure out what it is, right? For example, back in the 1800s, an engineer named Alexander Graham Bell was trying to come up with a simpler, cheaper way for people to communicate. Back then, the best you could do was a telegraph, which was an old-fashioned system of sending messages over electrical wires. Bell identified his problem. Communicating with people who were far away was expensive and took a lot of time. So his invention, or solution to this problem, was something you may have heard of. The telephone. Nice. Now, once you figured out what problem you want to tackle, you need to do your research. You can start by just making a list of questions you have and what information you need to start answering them. You can also look around and find what other things already exist that have tried to solve the same problem. Maybe they can be improved. A good example here is the man who helped us blow stuff up. The chemist and engineer Alfred Nobel invented the explosive known as dynamite, not because he particularly enjoyed explosions, but because miners and other people who, well, needed to blow stuff up to do their jobs, needed an explosive that was safer to use. So before he started on that problem, Nobel did research to see what explosives already existed, which ones worked well and which ones didn't. This takes us to step 3. Develop a solution. After your research is done, this is where you say exactly how you think you can solve the problem. And once you've thought of a good solution, you have to figure out how it'll actually work and what it will look like. So you have to design your solution. This is where you get to draw. Civil engineers always sketch out their ideas, like buildings and bridges and towers, to show what they'll look like when they're done. Gustave Eiffel designed the famous Eiffel Tower in France, and he definitely showed up on day 1 of construction knowing exactly what it was gonna look like. On to step 5, build a prototype. A prototype is just a simple model that lets you test out your design. It can be as big as the real thing's going to be, or it can be a smaller version. You just need to have a prototype so you can test it. This may be the most important step in the whole process. Engineers need to test their design to see if it works like they want it to. So, say if your building's a big tower, does it stand up? Does it stay standing up? If you're designing something with moving parts, does it work the way you want? Now take it from me, my future engineers. You might have a great idea, a really terrific solution to a really big problem. But when you get to this step, your prototype probably won't work exactly the way you want. At least, not on the first try. Most engineers test their prototypes over and over and over again. That's why a lot of time and brain power goes into the very last step. Evaluating your solutions. Evaluating just means asking yourself whether things are working the way you want, or why they are, or aren't. I like to think of this step as question everything. This is when engineers review all of the facts and ask themselves questions, followed by even more questions. What worked well? Why did it work? Why didn't it work? How could it be made better? And most of the time, the answers to these questions are going to send you back several steps. Like, once you figured out why your prototype wasn't working, you'll have to design a new solution and then build it and then test it again. Sometimes engineers go through this process 4, 5, even 6 times or more. Take Willis Carrier, the inventor of modern air conditioning. He tested his prototypes for years before he figured out the design that worked the way he wanted and solved the problem he wanted to fix. Like all engineers, he failed a lot before he succeeded. And that's okay, because he learned something from every failure, which made his product even better in the end. And I, for one, am glad he kept going. So the engineering process is a series of steps that engineers, or anyone, should use when they're facing a challenge. The process is important because it allows engineers to experiment and also to fail. Both of these things give engineers a chance to go back and improve on their original idea, giving us something even better down the road. So the next time you fail at something, don't feel too bad. Think about the telephone and the air conditioner and the Eiffel Tower, and then try again.
Engineers make mistakes, and when you are working as an engineer, your first idea isn't going to work the way you expect it to. And it's important to know that when engineers make mistakes, they don't cry and they don't get upset. They say, thank you, God, I'm going to learn from that. And then they make changes and they make improvements to their ideas. So that was, there were a lot of words in that video. It was maybe intended for kids slightly older than you, but I hope you got the idea. I want to show you a different version, a different way of looking at the engineering design process, and then we're going to simplify it a little bit so that it works for us in first grade. So we're going to watch one more video.
The essence of engineering is solving a problem using scientific and technological tools. Let's take a look at exactly how this works.
I can't see.
We simply wave our engineering wands at it, and suddenly a solution appears. Wasn't that easy? Okay, well, there are two things very wrong with this picture. First of all, you should never swing your tools around in the air. Give me the wrench. Second, there's obviously no easy engineering magic way of solving real problems like this. Engineering means using a logical and systematic way of addressing a problem that allows you to come up with a solution. But it's not magic, it's logic. Okay, problem solving, take two. We start with a problem. Let's say we need to get from here to here. Since we can't use magic, we'll just have to sit down and think up an idea. And then we build the thing we thought of. And voila, solution. What the heck? Did you guys even test that thing? Okay, third try's the charm, right? Start with a problem, then instead of taking the first idea that pops into our heads, let's get a bunch of ideas, collect them, and pick the best one. Now let's build based on that idea and test the product to make sure it actually works. If something doesn't work quite right, let's change the design slightly to fix the problem and try again. And repeat that until everything works. Now we take our solution and sell it to, hi there. Well, it looks like we may have another problem, or two. Let's add in here, when you start with a problem, you should probably do a bit of research on it first. Clearly, we didn't quite understand just who was going to be using our product. And I guess we didn't quite understand the terrain that our vehicle was going to be operating on, both of which would have heavily influenced our design. All right, so it took us a couple tries, but at last, now we've got another problem. We took too long getting our solution finished and sold. Maybe next time we ought to try planning ahead a little so this doesn't happen. Well, we learned some lessons the hard way here, but fortunately, you can avoid making the same mistakes. Engineering is about building solutions to problems, yes, but really solving them requires you to avoid these pitfalls. Engineering a real solution to a real problem includes the necessary research, planning, prototyping, testing, and commercialization processes to ensure real success.
All right. So that is a lot of words that are intended for kids a little bit older than you. But I'm going to try to put this into first grade terms. So Jeremy and Lulu in Seesaw is a copy of the engineering design process chart. It looks like, I'll show you what it looks like. Hold on a sec. And I hope you can pull it up because this is what we're going to be looking at in class. It looks like this. So if you can pull it up in Seesaw or print it off, but if you can at least look at it while we're talking about it, that would be great. And then first graders, I'm going to pass out an example of the engineering design process, and going to ask you to write your name and number at the top of this paper. Okay, so Lillian, did you just interrupt our class? So first grade, we're not going to get upset about bees. We're not going to freak out. They are God's creatures and they will not hurt you unless you try to hurt them. So I would just ignore them. And I do see Harley messing with his name tag. So those name tags on your desks first grade cost a lot of money. You get one a year. So if you peel it off and pull it off, you're not getting another one. And those name tags are really helpful. They help you spelling your first name and last name. They help you with your colors. They help you with your ABC order and your number order and your shapes and your left and right and your hundreds chart. So please do not mess with those name tags. Okay? All right, so Lulu and Jeremiah, I'm going to pass out papers and then I'll be right back with you. So please put your name number on this paper. So you read up pencil. This chart is called the engineering design process. Please write your name and number at the top. Please write your name and number at the top. Okay. When you have your name and number written, please circle it and then check somebody near you. If they have their name and number, give them a thumbs up. If not, please give them a, well, point to what they need to do. Point to where they need to write their name and number. This is being a good friend by helping out. So this paper that you have in front of you has the engineering design process, which is the same process that's in this chart over here. And it starts at the top. So the first step in the engineering process is ASK at the top of the chart, which spells ask. So both of the videos we watched talk about how engineers ask, what is the problem that we need to solve? And what do I need to know to come up with a good solution? So you can't come up with a solution until you understand the problem. So that's what ask means. It means asking about the problem. All right, so in the video, they talked about the person who invented air conditioning. So when I was your age, there was not much air conditioning in the world. We didn't grow up with air conditioning. If you were hot, you were hot. So the problem was that people were hot, and some people were so hot that they got sick or even had to go to the hospital because they were too hot. So that was one problem. Another problem is that people were not able to do a very good job at their work because they were so hot. So that's an example of asking and trying to understand the problem. All right, Caitlin? Yeah, exactly. All right, so then you follow the arrow from the top, you go down to the right, the next rectangle, it says explore, explore. To explore means to learn about. So after you understand what the problem is, you want to start exploring your possible solutions. This means, in first grade, it means thinking up any possible idea to solve the problem, even if the idea is crazy. It might seem crazy at first. We're not going to rule out any ideas. Get all your ideas on paper. So big bigger kids and grown-ups call this brainstorming. Can you say that? Yeah, which means you just write down on a piece of paper or on a whiteboard every idea that comes up, whether it's good, bad, or crazy. Do you remember the video we watched last week about the space station? And they had a problem where the space station needed to be fixed. And they came up with a bunch of ideas, no matter how silly they were. One idea was to send a truck into space. One idea was to send a pigeon into space, right? One idea was to send a crane up into space. And one idea was to invent a new spacesuit that had jetpacks on the back of it. So some of those ideas were crazy. They all were kind of far-fetched or radical. But then when they had those ideas down on paper, then they could figure out, well, which one is the most likely to work out? And it was the spacesuit with jetpacks on the back. So that's the explore stage, where you look at all your possible ideas, and then the next step down towards the bottom of the page, MODEL, is model. Can you say that? Model. To model means to make an example of your solution. So after you brainstorm all your ideas, you come up with a solution, and then you make a mini example of your solution or of your invention. The reason we make a model is because you don't want to put the time and the money and the resources into making an invention till you're pretty sure it's going to work. So a model can help you figure out if it's likely to work. After you build your model, the next step, evaluate, is that's where you test it out to see if it works. So with the space pack example with the space station, they tested it out, and one time the jetpacks didn't work so well, and the spacesuit went off into space, right? Because it didn't go where they needed it to go. And I guarantee you, there is no invention in the world that works the first time. So during the evaluate stage, that's where you're going to test it out, expect something to go wrong, and then you go to the explain stage, which is the last stage, where you figure out what went wrong and why did it go wrong and how could I make it better. William?
Can we draw the stuff that, like, if we know what it looks like, can we draw it?
Well, there will be a time when you can, but we're actually about to move on to something else, so I don't think there'll be time to draw it right now. All right, but an important thing is, do you see how the arrows keep going? There's actually an arrow that goes all the way around in one direction, but they also go backwards. That's because it is possible that if you explain what went wrong, you could just go back. If you can fix your model, you could go back and test it, go back to the evaluate stage and test it. Or you can go back up to the ask step, because you might have discovered a new problem when you think through and talk about what went wrong and why did it go wrong. So then the engineering process doesn't really stop. Then you go back. So if something goes wrong and you talk about it, then you go back to the ask. Well, why did it go wrong? And then you go to the explore stage, where you think up of possible solutions to what went wrong. Any solution, doesn't matter if it's crazy or not. Then you go down to model, where you make a new version of your invention that has some changes to it so that you won't have the same problems as the first time. And then you test it out to see if your changes worked. And if the changes worked, then you explain, well, why did they work? And if they didn't work, well, then you have to keep going. you go back up here to ask, and you ask, why didn't it work? Right? And then you do some more exploring where you explore, well, what would be possible solutions? And you go through this process over and over and over until you've got an invention that works. I think they said that the engineer who invented air conditioning, I think he went through this process 7 or 8 times before he finally had a solution. Right? So part of engineering is we don't give up and we don't get frustrated by mistakes. We learn from them. Okay, so your job today and tomorrow is going, actually today and Wednesday, is we're going to, I'm going to give you a problem that I'd like you to try using the engineering design process on. So are you ready for it? William, do you have a question?
I have some like snaps of it that I could.
I'm sorry?
I have some like snaps of it.
Cool. So you could use those, you could use the engineering design process to create inventions using those snaps. All right, now I'm going to ask you to, can you put your paper on the corner of your desk? Put your pencil in your desk. So I know who's listening because their paper's on the corner of their desk, their pencil's in their desk. All right, so this is your challenge. This is the problem. I'm about to give you a problem that you're going to try to use the engineering process on. And your problem is that you need to build the tallest building that you can create. But the problem with that is all you have to build it with is 10 pieces of spaghetti. So I'm going to give each of you, or Jeremiah and Lulu, you're going to get 10 pieces of uncooked spaghetti. Okay. You're going to get a roll of tape. And you're going to get 1 marshmallow. The marshmallows and spaghetti are not for eating. They are building materials in this exercise. So your challenge is, how can you build the tallest building out of just 10 pieces of spaghetti, tape, and marshmallows? So your job is to think of a solution. So what I would like you to do in just a minute is you're going to do the first step, which is the explore step, because we just did the ask step. And if you have questions, like I saw a few people raising their hands, we'll do the ask step. And then you're going to explore by thinking of ideas, drawing diagrams on a piece of paper, and you're going to come up with ideas. The thing is that a piece of spaghetti is not going to stand up. You know, if I just, Lulu and Jeremiah have a piece of spaghetti that I'm holding up for the class, and if I put it on my desk like this, it's not going to stand up on its own. You're going to have to think of some way for it to stand up on its own, to support its weight. So that's why I am giving you not just 1 piece, but 10 pieces, and tape, and the 1 marshmallow. Now, if you want, you can break the marshmallow up into smaller pieces, if you think that would help. And you can use as much tape as you have on your roll if you want. So that should help. So when you are doing your exploring stage, you're going to need to think about different ways that you can get the spaghetti to stand up. your building, or it can be any shape you want. But after we go through this process, I'm going to take my tape measure and I'm going to measure everybody's building from the ground to the highest point. And the person who comes up with the tallest spaghetti building is the person who wins. Now, in the past, we have done this project in teams, but in COVID, with the virus, we don't think that's safe. So one part of the engineering process that's not as realistic, in the real world, if there wasn't a virus, you would be working with other engineers. But we want to be safe. So instead, for this exercise, you're going to use the process, but you're going to work on your own. Each of you is on your own. Okay? So you're going to do your own thinking and you're going to try out your ideas. All right? So we have a couple questions. So before we leave the Ask stage, Lillian's been waiting and Lucas has a question. So Lillian?
Invisible friends.
Say that again?
Invisible friends.
Okay, if you want to kind of imagine that you have invisible friends helping you out, that's a great idea. William? Yes. So later this year, we hope to have some engineers come, but that depends on the virus. Because right now, no visitors are allowed in our school, but we think that in a few months, that'll change. So when that changes, we'll definitely get some engineers into our school. So the question is right now, do you have any questions about the project that I just described to you? Any questions about the challenge, the problem, which is to create the tallest building you can out of 10 pieces of spaghetti, 1 roll of tape, and 1 marshmallow? Questions about that, Henry? Yep, we're all gonna measure. You're gonna see as I measure them together. So let me just check with Jeremiah and Lulu. Do you have any questions about this challenge? Then your job at home is to get out a piece of paper and to draw a diagram. And first grade, your challenge here is to take out your first grade notebook. So please take out your first grade notebook. And at home, you can use any kind of paper that you have at home or a notebook. And you're going to think of ways to build a building out of 10 pieces of spaghetti, right? 1 roll of tape and 1 marshmallow. Okay. So Jeremiah and Lulu, your job right now is to just work on your diagram, come up with some ideas, label every part of your picture. So label the 10 pieces of spaghetti, label where you're going to have tape, and label where the marshmallow will be. You don't have to spell words perfectly. When I say label, like when you draw your spaghetti, you can just say SP for spaghetti, or T for tape, or M for marshmallow, or you can sound out the whole word. Okay? You have questions about what you're going to do? You can work on this a little bit today, and then we'll work on it again on Wednesday. We don't have science tomorrow. If it seems like it makes sense, then you can give me a thumbs up. All right, if any questions come up, you can email them to me or have your mom or dad email them to me, okay? All right, I'm going to let you guys go. We'll see you for religion in about 13 minutes. All right? All right, I'll see you.